In this video, we're going to look at sets questions. So the first question, 80 students in a group were asked what they had done during their summer holidays. Some had got a job, which is this J here on the sets, and some had gone on holidays. So a fifth of the groups did neither. I'm going to use decimals here, 0.2 on the outside. Everything inside the set has to add up to 1. 25% got a job, so section 1 and section 2 add up to 0.25. And of those who got a job, half went on holidays. So work out the total number of students in the group who went on holidays, and you may use the Venn diagram to help you answer the question. So 25% got a job, and of those who got a job, half also went on holidays. So that's half of 25 will be 12.5, 0.125 in both. So that's 0.25 and 0.2, 0.45. So there's 0.55 in holidays. So 1 minus 0.45 is what's left. And we already have 0.125 in there, so we need to take that away from 0.55 to get 0. That will leave 42.5, 425. So 0.55 go on holidays. 0.55 multiplied by 80 will give 44 students went on holidays. Another way to look at it will be 25% of the students got a job, which is a quarter of 80. So that would be 20. So half of them, 10 and 10 in there. What did we have on the outside? 20% of 80 was 16 on the outside, which adds up to 36. 20, 20, 20, 10, 10, and 16 is 36. So that leaves 44 students in total to get me up to 80. So I've already got 10 in the middle, so there'll be 34 in there, and you can see that will be 44 students as well. So whatever way you choose to approach this question. In this question, we're told sets A, B, and C are as follows. A is a set of multiples of 2, 2, 4, 6, 8, 10, 12, and so on. If we extend it a bit, B is a set of multiples of 3, 3, 6, 9, 12, 15, and so on. And 4 is the multiples of C is the multiples of 4, 4, 8, 12. The reason I'm writing these is we're asked to write a number that's in all of them. You can see 12 is the first number that's in all of them. And why is C a subset of A? Because all multiples of 4 are also multiples of 2. So sometimes questions can be quite easy. Don't give up on any of them, read them carefully. Nice easy sets question. So these are the sets A, B, and C. There's 7 different regions in the diagram. And we're told in part C, because C is a subset of A, so let's just put a circle around A. C is a subset of A, so this part here is a subset of A. So these two have to have elements. So the ones that don't have elements, there can't be anything in here because all of C has to be in A. So put an X in those two. And then in each of the other 5 regions, there are some elements. And we're asked to write one of the elements in that region. So 2 can go in here because it's definitely not a multiple of 4. The one that's in all 3 we have from earlier was 12. 3 can go in on its own. It's not a multiple of anything else. We give them dots. So then we're left with a multiple of 3 and a multiple of 2. That's not a multiple of 4. So 6 can go in here. So we're left then with a multiple of 4 and a multiple of 2. That's not a multiple of 3. Well, 8 could go in here. It's not a multiple of 3. So I think that completes this question. In this question, we have a max part to it. The Venn diagram shows the number of people in a U club who play music and sport. And we're given some numbers in the Venn diagram. We have a 1, 2, 5. Let's add them all together. That's the max who could be in the U club. 125, 52, 184, 184 minus n and 2n. So what do we have here? We have 359 plus n in the region, and then we're thinking about max and min. So let's give some numbers here. And before I start looking further, you may add them together properly. Check your answer on a calculator. 4, 5 and 2 is 11, not 9. So 361 plus n. So we look at some values for n. Well, n can't be bigger than 184, but it could be 184. Let's try if n is 184. See, will this help us? If n is 184, we have 361 plus 184. So n can be smaller than 184, it could be any number down to number 1. If n is 1, we just have a plus 1 here. So n as 184 looks like the biggest number it can be. So it's 361 plus 184. It's going to be 545 will be the max number in this club. In this question, we have a 3 sets question. Find the value of x, just looking down to part B. So this whole video will have a variety of the type of questions that you can have. X have WhatsApp and Snapchat, but not Instagram. So here we have WhatsApp, Instagram, and Snapchat. So X is the key to this one. So 36 have WhatsApp equals 36. 40 have Instagram equals 40. 54 have Snapchat equals 54. So just tick them off. We've used these 3. 14 have WhatsApp and Instagram. So the question that you have to ask yourself is the 14 in both of them, or is it just in the top one? So we'll come back to that in a second. 8 students have all 3. So let's put that one in. This 8 students have all 3. So if 14 have WhatsApp and Instagram, if we put 14 here, that would be 22 have WhatsApp and Instagram. So it has to be 6 and 8, 14. 24 have Instagram and Snapchat. So if I put 24 there, you can see there's too many in there. So it has to be the difference between the two. So 16 and 8 is 24. That enables me to get what's left in Instagram. We have 14 and 16, 30 in there so far. With the 6, the 8 and the 16. 6 plus 8 plus 16 is 30. Just check. So we have 10 left. 40 minus the 30 will be 10. And we have X is WhatsApp and Snapchat, but not Instagram, but not is the key here, that one there. So we have 36 in total. I'm going to change color and go around this. We have 36 inside here. So we have 36 in there. We have 6 plus 8 plus X. So we have 14 plus X. So what has to go in here for this to add up to 30? 16 and 14 is 30. You can see that these now add up to 30. The X is cancelled. So this has to be 16 minus X. And similarly down the bottom, if I change the color just to show you, we have in this circle 54, but we currently have 16 and 8, 24. So we've 24 plus X in the red circle. It can only add up to 54. So we have to have 30 minus X. That's what's missing. 30 minus X. So let's add all these together. There's 80 students you can see here in the school. So we add them all together. In the blue circle, we already have added these to be 40. So just a bit of rough work. We have 40 in the blue. What's left in the other 3? These are the only other 3 sections left. 30 minus X. 16 minus X. And the X, add all these together, we get 70 and 16, 86. This X and this one will cancel. 86 minus X is equal to 80. So therefore X would have to be equal to 6. I'm seeing a mistake here. This is 36 in WhatsApp. I had 30. I was thinking 30, so 36 would make that 22 minus X. So it's always good to go back and check in your work. 22 minus x would be 36, not 16. 22 minus x, that'll be 22. So that would mean that would add up to 70 and 22. 92 minus x is 80, so x would in fact be 12. Don't be worried about making mistakes, it's all about checking them. In this question, it's based on the previous one. We're asked to fill in the missing blanks. 8 is the number of students who have all three. You should be able to read these statements. Number who have all three. We'll just go back and check that now. Have 8 got all three? You can see in the middle they do. 24 students have Instagram and Snapchat. So I intersection S is 24. So the number in I intersection S is equal to 24. 10 is the number in I less W union S. So let's look where the 10 is. I less the other two. So Instagram only. Instagram only. And more students have Snapchat than have WhatsApp. That would be S. Snapchat, more have Snapchat. S is greater than W, so the number in S is greater than the number in W. So they're just trying to get you to fill in these blanks. In this question we have two sets, and they do make them a little bit tricky. Give an example of two non-empty sets, A and B, for which A intersection B is equal to A. Well, I like to draw these. Let's draw A and B. A and B. So for A intersection B to be equal to A, so let's put a number in here. Let's put 1 in there. So 1 is in the intersection, so that means that the set A can just have that element in it, 1. And the set B has to have 1 in it. B is equal to 1. And it could just be 1, but let's have a 2. Let's give it a 2 as well. So B could be 1 and 2. Therefore, A intersection B is equal to A. And give an example of two non-empty sets, P and Q, for which P less Q is equal to P. Well, let's draw a couple again. P and Q. Do you know your areas? This is P less Q. So we want P less Q to be equal to P. So let's put 1 in here. So we can't have anything in the intersection, but we could have a number in here. We could have a 2 and a 3 in here. So let's just write that. P is 1. And Q could be 2 and 3. See there, we put these elements in. There's nothing in the intersection, and P less Q is equal to P. So I think drawing them out definitely helps in this type of question. You can use any numbers, you could use letters. They don't specifically specify, but I've just used the first couple of numbers that came to mind. This is another two sets question. Connor carries out a survey on 25 students in his class. And we're given a universal set, so there may be some on the outside, and it does say he asked if they own a pet or a bicycle, P and Q. 6 own neither, so there's 6 on the outside, which leaves 19 in the middle 3 boxes. And it tells us here 28% of the students own both a pet and a bicycle, so bringing percentages in. So 25 by 0.28 is equal to 7. So we have 7 on both. 7 on both, so that's going to leave now 12. I'm just jotting down some rough work here. And P less Q to Q less P is twice as big. Ratio again, you've seen these ratio questions. Add the parts together. 2 plus 1 is 3. 3 parts, and there's 12 altogether. So 12 divided by 3 is 4 in each part. So 2 parts would have 8 and 1 part would have 4. So we have to have P less Q is twice as big, 8 and 4. And 8, 7, 15 and 4, 19 and 6 is 25. So that's how you answer this question. So mixing it up again with a 3 sets question. Sets A, B and C. So let's start with number 1 in A is 1 in either of the other two. It is. It's in A and C, but not in B. A and C, but not in B. Number 2 is in A and B, but not in C. Number 2. Number 3 is in A, C, just A and C. Number 3 is not in B. Number 5 is in all three. And then number 6 just looks to be in A only. Then number 7 also looks to be in A only. Now I go to B. Number 4 wasn't ticked. It's also in C, we can see that. So B and C have 4. I'm now left with number 8, which just looks to be in B. Number 8 and number 9 also just looks to be in B. And then I go to C and see what's left, just number 10. Number 10 is just in C. A union B is everything inside A and B, inside these two circles. They don't have to be in numerical order here. So I'm just going to go left to right, 6, 7, 1, 3, 5, and 2. You could reorder them if you wanted. A less C. Well, A less C is everything that's in A, take away anything that's in C. So we'd have to take away this section here that's in C. We'd be left with 2, 6, and 7. And A union B intersection C. So let's do B intersection C first. And then union it with A. There's B intersection C. And then we have that with all of A. So everything that's highlighted would be everything apart from 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. This 3 sets question, we have a researcher found all census data about measles, chickenpox, and whooping cough. Group of 100 children. U is equal to 100. Everything inside the box adds to 100. Starts with none. 31 had none. 31 on the outside. I'm just going to jot down, that leaves 69. 2 had all 3. 2 in the middle. 2 had measles and chicken, M and C but not W. M and C but not W is here. M and C but not W. 6 had whooping and chickenpox. 6, 2 and 4 is 6. 11 had at least 2. Well, that means that these 4 boxes, at least 2 is these 4. We already have 8 in there, which leaves 3 to make it up to 11. So I'm going to take, well, let me use that in a minute. 18 had measles. We have 3, 2, and 2, so we 7 in there, which leaves 11. Just double check that. 3 and 2, 5 and 2, 7, and 11 is 18 had measles. 40 had chickenpox. Well, we've 4, 2, and 2. We've 8 in there, so for chickenpox that leaves 32. So find the probability that a child chosen at random had chickenpox. Doesn't tell us anything about this section here, so we need to find this one. Although we have chickenpox, we don't actually need that one. We have chickenpox is going to be probability that the child had chickenpox. Well, we're told chickenpox is 40, so 40 over 100. But let's find the missing number anyway. We have inside chickenpox 40. We have 31 on the outside. And then all that leaves is the 11 and the 3. That's 14. 70, 85, which leaves another 15 in here. There was another part to that question, but I haven't got it here. So let's move on to this 3 sets one. A group of 100 students were surveyed whether they drank tea, coffee, or soft drink. So U is equal to 100. 24 is the first one, had not drunk any. 24. 51 drank tea or coffee, but not a soft drink. 51 tea and coffee, not a soft drink. 41 drank tea. Okay, we just put T equals 41 over here. 20 drank at least 2, so that's these 4 sections. is going to add up to 20, the 2s and the 3s. 8 drank tea and a soft drink but not coffee. This one, 8 tea and a soft drink but not coffee is 8. 9 drank a soft drink and coffee, 9. So it has to be this one and this one add up to 9. And 4 drank all 3. So 4 drank all 3, that leaves 5 here. And I'm reading the 51 wrong, I'm just checking. 51 drank tea or coffee but not a soft drink. Tea or coffee. So we need to just do a little bit of manipulation here. Let's go back to the at least 2 of the 3. 20 drank at least 2. So that's, we have already 12 and 5, 17 in there. So that leaves 3. 41 drank tea. So in tea we now have our 8, our 3 and our 4, which is 15. So 41 minus 15 is 26. That leaves 26 there. And back to our 51 now, the key to this question. 51 drank tea or coffee but not a soft drink. So what areas are they in? Tea, coffee. That's tea on its own. That's tea and coffee, and that's coffee on its own. So these 3 dots have to add up to the 51. So 26 and 3, 29. So 51 minus 29 is 22. This would have to be 22. And let's see what these all add up to. We have 41 inside T. These add up to 41. We have a 22 and we have a 5. So that adds up to 68. We also have the 24 on the outside, bringing me up to 92, 88 and 4. So that leaves 8. So this must be 8 here. Find the probability that a student at random I'm drunk. Find the probability that a student chosen at random from the group had drunk tea or coffee. Well, tea or coffee is everything except this one and this one. So that's 32. 100 minus 32 is 68. So 68 inside those 2 boxes, 68 over 100. And find the probability that a student chosen at random from the group had drunk tea and coffee but not a soft drink. Tea and coffee but not a soft drink. So tea and coffee is this one here. Tea and coffee but not a soft drink is my 3. So 3 over 100. So another 3 sets question. Complete the Venn diagram and list the elements. So A has 2, so does B. C doesn't, so A and B has 2. A has 3, only A has 3. A has 4, so does B, and so does C, so 4. A has 5, only A has 5. A has 6, so does B. A and B have 6. And then that's all of A, so on to 8 and B. B has 8, and so does C, so B and C have 8. B has 10, just B on its own has 10, and that leaves everything else in C. So 1, 12, 14, 1, 12, and 14. So anything common to A and C, 2, 3, just the 4, 2, 3, 4, 5, 6, yeah, just the 4, just checking. So A intersection B. This is A intersection B, 2, 4, 6, 2, 4, and 6. B less A intersection C, so the answer has to come from B. There's B. We have to take out A intersection C, so let's put a different color on A intersection C. So we have to take out anything that will be in there. So that's just the 4, so 2, 6, 8, 10. So 2, 6, 8, 10. 2, 6, 8, and 10. And B less A, just let me get rid of the lines. B less A is going to be, if we look at just 2 sets, A and B. B less A is this one. So So I've got my 10 and my 8. So that's B less A. We're unioning that with B less C. So I take my B and my C. Everything in B. That's not in C. So that will be going in this direction. Everything not in C. So what have I covered there? 2, 6, and 10. 2, 6, and 10. And write down a null set. Well, in terms of A, B, and C, this is the null set. So that's, we want A, B, and C. So let's just think about that for a second. We could just write in terms of A and C quite easily, but in terms of A, B, and C, I'm just glanced back at the set. I've left out the 8 here. I did have the line across it, 2, 6, 8, and 10. Just be careful. So if we think about this one, this would be, if we think about this one as well, A intersection B, or A intersection C, and then take away part of B, that would give us the bit on its own, A intersection C, and then we got to take away that 4, which is in B. So I think that's good enough for this one, A intersection C less B. And the last question in this video is a max min question, which they love. Team N, 100 questions, U is equal to 100. M answered 72 and N answered 38. So M equals 72 and N equals 38. Well, if we add them together, we get 110. So we could have 10 in the intersection. I'll just come back and look at the minimum now in a second. And that would be 62 and 28. That's the normal way we do these. So with the aid of the Venn diagram, the minimum number of questions answered correctly by each team. And then with the aid of the Venn diagram, the maximum answered correctly by both teams. So I just jump down to the second. What if we had a 72 in here? We can't have a 72 in there because we couldn't have a 38 in here. It would add up to more than 110. So if we have a 38, let's say the 38 that N got, M also got, so that would have a 0. They didn't answer any on their own. There was 38 easy ones. That would leave 34 here. Does that give me a max and a min? So we're asked for the number answered correctly by both teams. So it's the intersection that we're looking at. So I think this is the right answer here. The minimum will be 10. And the max will be 38. That's this question, min max. Think about them a little bit and then fill in your values.